Hi everybody, this is the algebra trig pre-calc first video on proving trig identities. I'm going to do possibly 4 videos today. The first one is going to be the longest on proof. Essentially what we're going to do here is when we're proving things, we're going to make the left side look like the right side. You could make the right side look like the left side, but for the most part, you're going to make the left look like the right. It's almost like a geometry proof where you have to throw in all those postulates and theorems and why things are equal, why triangles are congruent. I know you guys probably loved that, but this is super similar to it in that way. So we have to figure out how we're going to do that, right? So the way we're going to end up doing that is that we're going to use our trig ratios or trig identities. I have these sheets and every year I make a ton of copies for kids because I don't make you guys memorize these. Although the highlighted ones, those are probably the ones that you're going to know. You're going to know the reciprocals, the quotient, and the Pythagorean. Now, for the Pythagorean ones, just keep in mind that like the sine squared plus the cosine squared equals 1, but we can change this form around if we need to. If I want the cosine squared by itself, couldn't I just subtract the sine squared? Yep, 1 minus the sine squared. There you go. And I could do that for all of those. So there's actually 3 variations, or there's this guy in 2 variations, this guy in 2 variations, and that guy in 2 variations. And I may have to use those. There's a little arrow by the even or the odd even identities because you may need those. I know on a worksheet I have, you do use those, but I don't use those that much. All the other things are things that in the past I've used. This year we didn't use them just because we were doing school differently. And then I have a blank unit circle. So I will send these out with your homework and I'll share that out with you guys. I don't know if you can make a copy or if you just want to write those down. I know I was working with a pre-calc kid and I just pretty much had her write all these things down. And then we actually took all these and we made them like cosine squared equaled, the sine squared equaled. We made this tangent squared equaled. We made this the cotangent squared equaled. So we did all those as well. All right, and I'll go back and forth. All right, so one of the first things I'm going to say, I'm going to just put these little asterisks down on this page. I'm going to go down to solve this tips to prove these. We're going to substitute trig identities. That are the same. All right. That's going to be the big thing. So I may refer back to that. Okay. Now, the first one we're going to do, and if you need to pause it because I have all of them written out, go ahead and pause it. I'm going to try to take these slow so I don't make a mistake. And if I do make a mistake, I might pause it just to be like, okay, what do I need to do? But I should be okay to get through about 7 of these. All right. So we're going to start with the cotangent of x plus the tangent of x equals the secant of x times the cosecant of x. I'm taking all these off the CPM lesson of this, and they use x's for all their angles. Just know I could change them to different letters. I also could use theta, and I think I do that in one of the next videos I do, okay? So first thing I'm going to do here, I'm going to change the left to the right. Most of these, you guys are going to change the left to the right. So first, a big thing, not only substituting, this kind of goes with the identities, we could change everything to sine and cosine. And I'm not going to do that on the right side. I'm just going to do that on the left side. So the cotangent is going to be the cosine of x over the sine of x. Plus the tangent is going to be the sine of x over the cosine of x. All right. So then the next thing I would do would be to ask you guys, okay, how do you add fractions? Because that's what we're going to do. Find a common denominator. So that's another thing. Find a common denominator. When adding or subtracting. Fractions. I might get off this a little bit, but what am I doing? Oh, I'm okay. All right. So that's what I'm going to do. My common denominator is going to be, and as I go through this, guys, just like a 2-column proof, I'm going down this way. Probably should have an equal sign because that should equal it. Okay, my common denominator has to contain a sine of x and a cosine of x. All right, so here we go. What do I need to multiply the guy on the left by so I get that common denominator? I need a cosine on the bottom, right? So do I need a cosine on the top? All right. Then the guy on the right. To get that common denominator, don't I have to multiply by a sine of x over a sine of x? Makes sense. So cosine sine, Feeling good about that. Okay, let's multiply these guys together. Isn't the cosine times the cosine squared of x, plus sine times sine is the sine squared of x. So that equals what we had before. Let's go to the next thing. Does anybody, and then at this point I'd say, does anybody see anything? Yes. Cosine squared plus sine squared is the same as sine squared plus cosine squared. That's 1. So I'm going to have 1 over the sine of x, cosine of x. All right? Now, one of the other tricks we can do is, rather than writing this as 1, couldn't I say, isn't this equivalent to 1 over the sine of x times 1 over the cosine of x? Right? All right, guys, what's 1 over the sine of x? That's the cosecant of x. What's 1 over the cosine? That's the secant of x. Aren't these two the same? Yep, that checks. Okay, so as we kind of go through, or as we do go through these, I will give you guys some pointers on this page. I'll come back to this constantly, but that is what I do. I've substituted some trig identities that are the same. Changing everything to sines and cosines is actually using your trig identities. And then one of the things we did is we found a common denominator. All right, number 2. Okay, 1 minus the sine of x times 1 plus the sine of x equals 1 over the tangent squared of x. All right, this one's going to be interesting because I'm going to look at it in a different way than I normally do. All right, I'm going to make the left side into the right side. First thing I would do would multiply those. So another thing we could do, multiply expressions. Okay, so if they're asking me to multiply, that's what I'm going to do. All right, 1 times 1 is 1. 1 times the sine of x is the sine of x. The negative sine of x times 1 is a negative sine of x. And then a negative sine of x times a positive sine of x is a negative sine squared of x. And that should equal that, right? Okay, does anything happen? Yep, this is gone because that's 0, right? So I get 1 minus the sine squared of x. All right, so then my next thing would be like, oh my gosh, what could that be? Well, I have a 1 and a sine. So let's think about this, you guys. If the sine squared of x plus the cosine squared of x equals 1, okay, if I subtract the sine squared from each side, which I can, wouldn't I get the cosine squared of x equals 1 minus the sine squared of x? I totally do, which is awesome. Awesome, yes. All right, so couldn't this here, couldn't we substitute the cosine squared? All right, so here's the thing. I'm not really seeing that, which kind of stinks, okay? That does kind of stink. So here's what I'm going to do next. Okay, the cosine squared. Okay, isn't the cosine squared the same thing as 1 over the secant squared of x? That's using my reciprocals. And here's the thing. On my reciprocal one, all of these guys, like I just said the cosine is 1 over the secant. The cosine squared would be 1 over the secant squared. I can square all these guys too. All right? Awesome. All right, so that's what I have next. And you can use arrows if you want, but these guys equaled, then these guys equaled, then those guys equaled, and that equaled that. All right, so I have this. Now I'm peeking. I'm always peeking over to see what I got. I like the 1. I need that. Now, what's 1 plus the tangent squared? Looking at this, isn't 1 plus the tangent squared the secant squared? Yep. So, if I got the secant squared here, couldn't I change that to 1 plus the tangent squared of x? That equals that, that equals. So again, I took the secant squared's here. Do I see that? Sorry. Secant squared's here, and I substituted 1 plus the tangent squared. I did that there. I'm done. That's my second one. All right, so I multiplied and I simplified. All right, that brings me to number 3. Okay, the third one, I got 1 over the secant squared of x plus 1 over the cosecant squared of x equals 1. All right, so here we go. Let's change everything to sines and cosines. So what's 1 over the secant squared? Okay, let's see here. 1 over the secant is the cosine. So 1 over the secant squared would be the cosine squared. Plus 1 over the cosecant squared. Well, if 1 over the cosecant is sine, wouldn't 1 over the cosecant squared be the sine squared? All right, what's the sine squared plus the cosine squared? That's 1. that equal to? So that's done. That was super simple. Question 3. Gosh, I hope they all are that simple, right, you guys? Next one. For number 4. Okay, I'm going to have the secant squared minus the cosecant squared. That equals the tangent squared minus the cotangent squared. All right, so here is what I would do for this one. There's a couple ways to do this one, and I think I'm going to do the easy way because I did it the first time with a difficult way. I feel like there's an easier way for this. And you know what? If I mess up, I'm just going to start over, okay? And I'll do it the other way. I'm seeing all these squared things, you guys, and I know that the secant squared, like in this thing, secant squared could have a tangent squared in it. I know that the cosecant squared could have a cotangent squared in it. I'm really feeling like this is the way to go, right? So I know that the secant squared is 1 plus the tangent squared. That's what I'm going to rewrite this as. This is 1 plus the tangent squared of x minus, and you don't have to put the first one in parentheses, but I would highly suggest you put the second one in parentheses. Cosecant squared is the tangent squared of the angle plus 1. So I'm going to take the cotangent squared plus 1. That should equal that. All right. Now, you can make this into a -1, or remember, isn't subtracting, adding the opposite. So this is going to be 1 plus the tangent squared of x. This is going to be minus the cotangent squared of x, and then minus 1. Okay? So looking at that, that was another step I used. I can either add the opposite or distribute a -1. All right, so here we go. What do I see? Is it 1 minus 1, 0? This is the tangent squared of x minus the cotangent squared of x. That equals, that checks. I'm going to be honest with you, guys. That's like way shorter than what I had before. I changed, if you want to look at it, I changed everything the first time to this is this guy right here. I changed everything to sines and cosines. That's longer. That's shorter. I've gotten better at these. So if I see squareds, that's what I do. I peek and I say, what can I use for those Pythagorean ones? Because that is the way to go. 5th one on this bad boy. All right. This one's going to take me a little longer, all right? So I got the secant of x over the tangent of x plus the cotangent of x. All right, so here we go. I don't like the denominator. I don't like actually the numerator either. So I'm going to do a couple things. You're going to see some big fractions, okay? So if you need to, because I'm going to actually do this, I'm going to make like wavy lines between each of my steps so that you can actually see them. I'm going to change everything to sines and cosines. This here is 1 over the cosine of x over, tangent is the sine of x over the cosine of x, plus the cotangent is the cosine of x over the sine of x. All right, so that is one step. I'll go to the next step. All right, I don't really like that denominator at all. The numerator I'm going to leave alone for a while, okay? So we're going to get to another funky step, but let's just take care of this because that's nasty. So I'm going to leave the 1 over the cosine of x alone. Let's focus on the denominator. It needs a common denominator. That would be the cosine of x times the sine of x, just like what we did before, right? All right, so here we go. In order to get a cosine sine here, wouldn't I need a sine, right? All right, and then on the other side, in order to get this denominator of here, don't I need to have a cosine cosine? Okay, because it has to be a form of 1. All right, so we're going to take sine of x times the sine of x is the sine squared of x, plus the cosine of x times the cosine of x is the cosine squared of x. All right, so we still see all that, which is good. All right, next step. I'm going to leave the 1 over the cosine of x alone. Over, what do you see? Well, isn't that 1? It's going to be 1 over the cosine of x times the sine of x. All right, so here's the next thing. This is super nasty. I do not like fraction ladders, and I'm sure you don't either. This is your division symbol. Let's rewrite division horizontally. So that'll be another step we can use. We can rewrite division horizontally. Now, some of you guys won't have to do this. You're going to be able to skip to the next step, but I'm just going to show you how this works. And then I might end up skipping the steps too. But that's what it means. So I'm going to have 1 over the cosine of x divided by 1 over the cosine of x times the sine of x. Okay? So this is going to give me another one. Rewrite as division. Divide. How do we divide fractions? Multiply by the reciprocal. And honestly, as I do this, you guys, I should be peeking over there. I have to get it to be the sine. All right, let's multiply by the reciprocal. 1 over the cosine times the cosine of x times the sine of x over 1. All right, then the next thing I'd say was, okay, next step, what do you see? Don't those divide out? This equals the sine of x. That checks. All right, so I feel like if you guys want to come up with like lines for every single step just so that you can see it or it's easier for me to see it, you can. But things that are a little more complex like this, whenever you have all these fractions, it might be easy. Or maybe I could have used a highlighter for each one. I'm just trying to make it so it's easy for you guys to see because this is pretty new for you. All right, so that is my 5th one. All right, so I have all those steps. All right, my 6th one. Like I said, this video is going to be 7. We're actually doing quite good on time, to tell you the truth. All right, for the 6th one, we're going to have the sine squared of x times the cotangent squared of x plus the cosine squared of x, tangent squared of x equals 1. And again, if you need to pause the video to write things down, go ahead. All right, so I'm seeing a lot of stuff here. I'm seeing some sines and cosines. I'm going to go with my first thing on this. Now, here's the other thing. I'm seeing a lot of squares, but if I'm changing like the sine squared to like 1 minus the cotangent squared, this is going to get to be a lot more messy, and I don't like that. So let's kind of simplify things by just changing everything to sines and cosines. So this is going to say the sine squared of x. That's going to be times the cotangent is the cosine squared of x over the sine squared of x. Now, since I'm multiplying fractions, I'm going to put this guy over 1 just because it's easier to see numerator and denominator. We're going to leave the cosine squared of x here, and that's going to be the sine squared of x over the cosine squared of x. Again, since I'm multiplying fractions, I'm going to do that. So, now, usually when I add, I'm trying to find a common denominator, which I 100% completely understand. But that's really not the goal of this. Do I see anything else? Yeah. Don't these sines divide out? Don't these cosine squareds divide out? And I'm left with the cosine squared of x plus the sine squared of x. What's that, you guys? 1. That checks. All right? So, the only reason I did this is because things did divide out. If I'm finding a common denominator, I don't want things to divide out. I want to actually find the common denominator. Here, I would do this stuff first, and then if I had to find a common denominator, I would. All right, so there was nothing really new in that one. I just changed everything to sines and cosines and solved it. And I think I'm to my last one. Yes, yes. Okay, so my last one is the cosecant squared of x minus 1. That's divided by the cosecant squared, and that's going to equal the cosine squared. All right? So I'm looking at this one, and I did it in one way, and I think I'm going to see how this goes. All right, so first thing I'm seeing is I got a lot of squares. I got a lot of them, all right? But I want to try to simplify some things here. So the cosecant squared of x minus 1, okay, so if I take the cotangent squared of x plus 1 equals the secant squared, right? Is that the one? Yeah, cosecant squared, sorry. Making sure. So I'm using this guy. All right. If I want to look at what this is, if I subtracted 1, wouldn't the cotangent squared of x equal the cosecant squared of x minus 1? That's good. See, here's the thing. I have this plus 1 in here. I want to get it down to 1 ratio. So I don't want a plus 1. So if I'm dealing with 2 ratios, this seems like a really good thing. So I'm going to change this to the cotangent squared of x over the cosecant squared of x. All right. Then the next thing I'm going to do is I'm going to change things to sines and cosines, which makes sense because the right side is a cosine. So this is going to be my big fraction bar compared to this, okay? I'll actually, this is that. All right. And I'm probably going to be having some fraction ladders, so I'm going to do this. I'll go step by step that way. Cotangent squared. The cotangent is the cosine over the sine. So this is going to be the cosine squared of x over the sine squared of x. The cosecant squared, isn't that 1 over the sine squared of x? Okay, next thing. Dividing. Doesn't that mean we're going to multiply by the reciprocal? So if you want to, you can do this. You can rewrite this out. You can do that, or you can jump from here straight to here. I'm actually okay with that. So you could take the cosine squared of x over the sine squared of x and multiply it right away by their reciprocal, which would be the sine squared of x over 1. What happens? These guys divide out. I'm left with the cosine squared of x. That's what I need. Boom, I'm done. Okay? So I actually did 7 of these in 20 minutes. Are there other ways to do this? Yeah, there are. I think I showed you how I did this the first time around. Looking at this guy, I did it the same way. But I have kids that do things differently than me, and I'm totally fine with that, just as long as things work and you're substituting things that make sense. All right? So that's your first one. I'm going to come up with another one in just a moment. All right?